All right, I wanted to talk about architecting and architecture in the world of software because I think there's often quite a bit of confusion. The act of architecting is consciously thinking about and weighing pros and cons of kind of two primary things. One is abstractions and the choices you make about those abstractions and what those abstractions let you do, and characteristics, right? So this could be like physical characteristics of something. So like, and this is true of systems level architecture, all the way down to every single line of code that you write in code, right? So when you're doing application level architecture, you're making decisions all the way up and down this entire stack. Um, so oftentimes people ask the question like, do you believe that architects should exist? These people up high that, you know, decide how a system should look in an idealized state and then lay that out in terms of systems architecture. I think, yes, my opinion is yes, architects should exist. And that's because um, it takes a lot of knowledge to be able to understand all the concepts and the characteristics and the effects of those characteristics, to be able to properly reason about those pros and cons of all of those things, especially in systems architecture. That's not to say you don't need to do it in application architecture, but I think my take is on application architecture is that it's really the responsibility of developers. So all developers in my mind need to be application architects as and evolve to being good application architects. In the case of systems architecture, I think there's more room for there to be a specialists who understand the constraints at that level. Um, but developers should also grow to eventually understand how the software they're writing fits into systems at a higher level, anyways. Um, so I think it helps to think about things in a more tangible manner. So let's take an example. Okay, so Flutter Forge is a library that I recently wrote in Flutter to um, build some structure around uh, building modular components in the Flutter space. Okay, and so like the things we're weighing everything against, one of those things is modularity, and that brings like in us into this like, well, how do we reason about these things when we're architecting, right? Because like in this context, we're doing it within application software architecture. So what do we use to determine whether which things are good, which things are bad, which abstractions are good, which characteristics are bad? And to do that, we have to kind of define some things we call core tenets, right? So if, for example, we looked at Flutter Forge's website and we went to our core tenets page, we can see here's our core tenets outlined. We have modular, needs to be testable, isolated, support composition, state-based, and facilitate UI overriding, right? So these are the core tenets of the architecture and the design that went into Flutter Forge. And so if we go back, we can start looking at some of those things, right? So one of the core things we have as part of Flutter Forge is based on Redux, right? So we have a widget, that's the UI layer. We have the state that the widget knows about and displays. And then we have actions that are triggered by the users. And those get fed into the reducer. And the reducer's job is to take an action, interpret it, and compute the new state that it then updates here, which then causes the widget to redraw itself with that new state, right? This is the the simple kind of Redux pattern right here, this loop, right? It's this unidirectional data flow architecture that controls that piece, right? Now, this is what you see everywhere when people talk about Redux is a simple loop, but in reality, you also have effects, right? Side effects. Because if you don't have any side effects, your application's not very interesting. If it doesn't go talk to something over the network, make changes on a server somewhere else over the network, or it doesn't write to the file system or read from the file system, it doesn't do any of these effectful things, your application's not going to be very interesting, right? So when we have a concept for that as well, which is when a reducer receives an action can also fire off effects. And then what those effects do is go run their effectful code and then return with optional actions back into the store. And the store then, hands this back to the reducer. The reducer processes those actions, potentially updates state, or potentially fires off more effects, etc. And then we have effects which depend on environment. An environment is just a class that we define that facilitates dependency injection. So it allows us to dependency inject into it any external dependencies. And oftentimes you could think about this classically as like you have a component which is a widget and the reducer logic for mutating the state and managing the state. And you want that thing to be reusable, but maybe it sets notification preferences. And in one case, you want those notification preferences to be able to be set inside of Iterable, right? A platform for sending communications to customers, for example, right? And so you could have in your environment an implementation that is Iterable specific that you inject into the environment. But you could also have any other communication platform and plug that into the environment instead. And none of this stuff would change on this other sides of these lines because we have this abstraction in place of the environment. So that's just one example of how this could look, but we can start to compare and contrast things a little bit by looking at what benefits does having this as an abstraction, this boundary here with environment, and having this iterable thing live outside of this provide for this? Well, one is it facilitates testing, easy testing, right? Facilitates injecting a stub implementation, right? If we didn't have environment exposed as an injectable thing, then it would be hard-coded into these effects, and we would have no way to override the actual effectful code that goes off and talks to Iterable over the network. Instead, we would, just have it baked in. And therefore, if we wrote a test that tests our widget, we wouldn't be able to change the effectful code out for a stub implementation. And that would make testing near impossible unless we were testing against the live server, which is extremely difficult, error prone, and not great for automated tests. So we can look at this example and we can say, okay, cool, this exists, this abstraction exists, and the reason we have this is to facilitate injecting stub implementation. If we were to eliminate environment as part of the interfaces and as an abstraction, we would be taking away the ability to test. Now, we can ask questions like, cool, well, can we bring that ability to test back in some other way? Sure. Let's say we standardized on using some dependency injection framework as part of the effects. Then if there's some global dependency injection framework, the effects could reach out to that global dependency injection framework and reconstitute instances of the dependencies that it needs to perform the effectful code. And then we've effectively done is we've kind of made that dependency injection less formal and we've moved it off to a global dependency injection framework. But now we've coupled this component to this global dependency injection framework, and it is no longer isolated just in its nature, right? So these are like the kinds of things that are evaluated when we are architecting. It is consciously looking at these abstractions, deciding where we need these boundaries and what benefits and like pros and cons we get from having them. So like in this case, the con is, well, we have to formally provide an environment class. Like you could argue, cool, well, like it's much easier from a usage standpoint if we just encapsulate the dependencies 100%. You're right. It is easier to call that, right? If I have a class that, has a effectful dependency, and I just write a function that takes the arguments it needs to execute the thing, and then, you know, has the dependency used inside of it, that's easier to call from a developer standpoint, a user standpoint, but it also makes that function not testable, right? Because there's no way to stub out that implementation. And so there's a lot of different concepts. Like it's important that you understand the core concepts and principles of programming languages, right? So like in this case, we're comparing dependency injection on a spectrum, and we're comparing encapsulation on a spectrum. And at one end, you have 100% encapsulation, but at 100% encapsulation, you lose the ability to test, right? So what we're doing in this case is going, okay, cool, well, if we went to 100% dependency injection, you're going to dependency inject everything. It kind of defeats the purpose in terms of design, and then it puts a bunch of more work on the consumer of that API, right? So instead, we're taking this stance of, cool, well, what if we just dependency inject the effectful pieces of code? Then that gets us somewhere closer to encapsulation, to 100% encapsulation, but not quite 100% encapsulation. And that gives us the ability to test while executing all of the rest of the code in an encapsulated fashion. So this is just an example of kind of what you're doing when you are architecting software at an application level. And so we have this with, we could look at the abstraction between the widget and the reducer, right? So right now in Flutter Forge, there's an abstraction that defines the state and the actions, which the widget owns, right? The state and the actions are defined strictly in the context of the widget. And then we have a reducer, and the reducer's job, as I said before, is to interpret the actions and determine what the new state is going to be when each of these actions happen, okay? Having this abstraction here facilitates being able to swap in different reducers. It also facilitates, so we can facilitates swapping in different reducers, or aka different logic. This also facilitates another characteristic related to testing, which is reducers are pure functions, right? Because we have separated this way, it is a pure function. This function takes in an action and current state, and it computes and returns a new state. Okay, so that's a pure function. It has no effects, no side effecting of itself, right? And that allows us to test reducers very easily, right? So having that separation there also facilitates testing the reducer in a trivial manner, right? So if we didn't have this abstraction, let's say if you got rid of this boundary, which we can then look at like, what would that leave us with? Well, okay, the widget wouldn't have actions that are necessarily here. This connection would be tightly defined, tightly connected, and state would be tightly connected between the reducer. We wouldn't be able to swap in a new reducer, and we wouldn't be able to test the reducer in isolation in a trivial manner at all. We wouldn't be able to test the reducer directly at all because the reducer would be encapsulated by the widget. So this is the process and what you do when you are architecting. It is all about comparing and evaluating what abstractions you want to put in place, where you want to put them to gain what benefits, or getting rid of them to lose what benefits, and then weighing the pros and the cons of all of those and making choices. And those conscious choices are, and the result of those is your architecture, right? So what's interesting is that people write code every day without thinking about architecture. And they end up with an architecture, but they haven't necessarily consciously designed it, right? So they haven't architected it. And I think when you start out as a developer early on, that's what you're doing, right? You are understanding the basics of how to make things work and make things happen. And as you go through your career, you should be learning more and more about all of these concepts like encapsulation or dependency injection, what they mean, like what the pros and the cons are as you do more things with them, you know, figuring out how to determine which boundaries you need to get what you want, and understanding like what core tenets you care about. What are the characteristics of the system that you are trying to build? If you're trying to build something testable, then you probably care about things that facilitate testing, right? And how much you care about those things becomes a question. Everything's like on a spectrum because everything is a choice, right? You're always comparing, contrasting, and choosing, and then moving forward from that choice. And those choices will impact other choices. And sometimes you'll be able to see that early on, sometimes you won't. It's just a process you go through as you're writing your code. But that is architecture. Fundamentally, it is just making choices. And it's exactly the same at the systems level, right? Like whether or not I want to use a queuing system or I want to have, you know, a non-queued system is an architectural choice at a systems architecture level. There are benefits of using a queuing system. There are benefits of not using a queuing system. There's cons of using a queuing system. There's cons of not using a queuing system. And so it's looking at what the core tenets are, the core tenets that we care about for the solution that we're trying to build, and weighing those against the characteristics of the various things, right? So if something's asynchronous or there's like, you know, waves of load where it's like at certain moments there's going to be high load, but they're asynchronous things that need to happen, well, then maybe a queuing system solves our problems and it's a good fit, right? Where a queuing system can load up a bunch of asynchronous jobs and they can get fed into a system and processed, you know, over time. They don't need immediate responses in terms of whatever they're doing. But in other systems where it's like, no, I need an immediate calculation on this value, okay, like queuing a job and doing that might not be the best approach for that solution, right? Because it has different core tenets than the one where, you know, we're trying to do something asynchronously. And there's different amounts of load over different times and all of those characteristics. So again, it's just looking at the characteristics, looking at what the core tenets are, and comparing and contrasting the abstractions and the characteristics to the core tenets to find a design that more closely meets your core tenets. Hope that helps. See you next time.